Hi guys, it's Leon here from the CXXQ team, and today I just want to give you a quick overview of like where we're at with CXXQ, where it can and can't be used already, and I'll also show a bit of the code later on for those interested. If you don't know yet, CXXQ are a way of introducing Rust code into Qt applications that we've been working on as an internal project for the last about 2 years. And the question that sometimes comes up, especially if you haven't used Rust before, is like, why do we even want to do this? Why is Rust cool? Why do I want to have it in my Qt application? The answer to that is first and foremost really memory safety. Rust by default gives you great memory safety. And in comparison to C++, that can actually give you a lot of benefit because still, even with established analysis tools like upsan, asan, and valgrind, even like big commercial projects still struggle with memory safety a lot, right? If you research this, it's actually a staggering amount of especially security-related issues that have to do with some kind of memory safety problem. And this is exactly where Rust can really, really help you. Because in Rust, you get memory safety by default. By default, you actually cannot segfault in Rust. You kind of have to opt in to doing anything that might cause memory unsafety. And therefore, you try to avoid it as much as possible. And the language really helps you to not make those mistakes and to kind of use the safe patterns by default, right? Use unique pointer by default instead of raw pointer is sort of the way of thinking about it, and also without a lot of the pitfalls that you might encounter in C++. And because you have that memory safety aspect, you actually also additionally just get safe and easy multi-threading almost for free, because Rust by definition already makes sure that there aren't two things reading from the same or writing to the same data location at once. So you really don't have data races in Rust by default, which makes multi-threading a lot easier. Then you also just get a lot of the advantages of modern languages in general. Like you get easy dependency management with the package manager called Cargo. You get a really nice compiler warnings. It's all just a lot simpler and easier to use than C++. But you still get the same bare metal access and performance they get from C++. You don't have a runtime or garbage collector. It's just as fast as C++. So don't think like Java or another like managed or interpreted language. It's actually still compiled to the same level of performance. And because of all of these awesome features, it's actually been the most loved programming language since 2016, according to the Stack Overflow developer survey running. Like from 2016 onward to this day, it's been the most loved programming language by developers, which I think is really quite a feat and can tell you like just how much it's a pleasure to use, really. And then for us, the question really is like, where do we see Rust for us, right? As a Qt shop, basically. And the point is really that we don't really want to exchange Qt for the foreseeable future for the presentation layer of our applications. Especially with QML, it's so easy to use. It has all the features. It has accessibility features. It can do translations, whatever you need, right? It can do all of that by default. But really, where most of the C++ code usually is in a C++ application is in the business logic and in the data. And that's really where Rust can come in handy, because it can do safe multi-threading. It can parse untrusted inputs. It's just very good at data accumulation. So that's really where we see Rust and where we want to use it. This is why we have started CXXQ, because we want to be able to use that safe Rust code and interact with Qt. And one goal is really to make both Rust code and Qt code, in that sense, idiomatic, even if they're interacting with each other. And you shouldn't really notice a barrier there as much as possible. And that's also why CXXQ is bidirectional. So you can go from Qt to Rust very easily, but also from Rust to Qt code. And it's very much built on modern Rust foundations, especially CXX, which is a project by Detalne. He is one of the main contributors to the Rust ecosystem. He already started a project to combine Rust and C++ with almost no runtime performance cost. Especially if you enable link time optimization, there should basically be no runtime penalty for interacting between the two languages. And it really does that by adding a lot of compile time safety checks and basically no runtime checks, which, as the two languages are at the same like low level, actually it aren't really necessary, right? You're just passing one pointer from one language to another, which doesn't really do anything. It's actually been very successful thus far. It's been used in industry both by, for example, Google and Facebook have mentioned that they're using CXX in production. Google are even building their own project on top of CXX at the moment. One of the things that you'll find very often in Rust, and which is also the case in CXX, is that it's intentionally restrictive and opinionated. It sort of pushes or forces you to do the right thing by default instead of like just hacking around. Point is really the sentence that you can see below is like the Rust code feels like Rust, C++ code feels like C++, not like the C-style FFI glue that you often have to write when you're interacting between different languages. And that, in our experience, really is the case. You really don't notice when you're calling code from another language from the other side. The way it works is you write this, what CXX calls bridge, which is just a Rust module. And you can sort of think of it like a C++ header file. You just declare, okay, I have these things in Rust that I want to expose to C++, and I have these C++ things that I want to use from Rust. And when you have this boundary, this bridge description, it then goes ahead and generates code for C++ that is, for one, just a bunch of header files that you can include from C++, and that then just has a normal C++ API, right? You have your class that you can call methods on, nothing special really, but in the end, it just ends up calling Rust code. On the Rust side, it actually uses Rust's very powerful macro system, and don't think like C preprocessor macros here. Like, these are much more sophisticated, much safer, much easier to use, and to generate then just Rust code, which has all the hidden C ABI underneath it to in the end still expose you a normal and safe, straightforward Rust API, and then internally call all the hidden C stuff that usually would have to write by hand. That's what CXX already can do. So it can basically generate you from a Rust struct. It can generate you a C++ class and the other way around. The question is, why do we even need CXXQ? What do we want to add? Why don't we just use CXX? And the problem we really run into with Qt is that Qt sort of extends the C++ language in a way. You have things like properties, you have QML invocable methods, you have signals and slots, and CXX just isn't built to express these. It's built to express core C++ features, not Qt features. And with CXXQt, we really just add these features on top of what CXX already can do. We basically just add an additional code generator on top of CXX to add those Qt features. Additionally, we also just write normal CXX bindings for some of the most common Qt types, be that QString, QPoint, these sorts of types. And we're also working on like QVector and the other template types, but these are a bit more difficult. So we'll get to those probably by the next release. And we have also been careful to try to make multi-threading, especially in Rust, relatively easy, so that you can easily update the Qt state from like a Rust background thread or a worker thread somewhere else in your program. And like with CXX itself, we're also trying to be restrictive and opinionated in a sense, and we're not trying to expose you all the Qt API, right? We're only wrapping those most common Qt types. And if you need a type, I don't know, like QPainter or something, you can pretty easily wrap that in CXX. Like, that's just, I'd say, like 50 lines of code that you have to write, and then you can just use QPainter in your normal code. But we don't do that for you. We only add kind of QObject functionality to CXX. So how does it work? It actually works very similar to CXX. So you have, in this case, a CXXQt macro on top that you add to your QObject description. It goes again these two ways. We generate code for C++/Qt, where we actually just generate a Qt object subclass like you would just write it normally, which is the Qt side code that you end up with. And we also do macro expansion on the Rust side to generate a struct that you can interact with that has all the Rust side data and the Rust side code. And in the middle, we then use CXX to actually interoperate, which again boils down to that C API, and it handles all the safety aspects for us, basically. The question also often came up with how do I integrate this? And it's actually pretty easy because with CMake, we already have integration via an existing project called Corrosion, right? You have Corrosion in your project until you have Rust in it. It's kind of the idea behind it, and that basically takes care of calling Cargo, which is the Rust package manager and compiler for you. And Cargo then just generates and builds the code normally for Rust, and then links all the Rust together as a static library. You then just have to add that static library to your CMake build, which Corrosion can already do for you. If you want, you can also do Cargo-only builds. In this case, we'll link Qt for you to your build, and that way you can basically get away without any C++ code except for like a few lines of boilerplate if you're using QML. And if you want to add another build system, right, you can also just do what Corrosion does internally, just run Cargo, you get a static library and a bunch of header files, and then you just add the header files to your C++ build and link the static library from Rust to it. And that's basically all there is to it. This sort of brings us to where CXXQt is suited. We really think that it's a good fit for like step-to-step ports to Rust, and especially teams like ours that already have Qt and C++ skills could really benefit, because we're not trying to completely get rid of C++ in that sense. We're trying to be able to interact as neatly as possible and really want to allow you to still use C++ if you need it and use Rust where you think it's appropriate, and also be able to integrate C++ libraries with your Rust code base if you want to. Like if you really want to just do plain Rust, no C++ or involved, then I don't think CXXQ is the best fit. You can try and do that if you're using QML, but it's not really what it's meant for. And in that case, might as well just use Slint and go with that. Our current status is that we've just recently released version 0.4, which now has these most essential features. We have signals, we have invocables, we have Q objects, right? So we have a lot of the basic Qt API wrapped as well. And now we're actually also really happy with the API that we've developed thus far, and we want to now start really building on top of that API, adding more features. For example, if you want to inherit from a base class, you can currently do it, but you can't get to the protected methods from that base class. So we want to add that as well, and add also support for more Qt types, especially the container types, which we currently don't support, or at least not easily. So we want to make that as easy as possible, and that's really our future direction, is basically making Q abstract item model subclasses as easy as possible, because that's really where you want to be, where you want to use CXXQt is for your backend, for your models. That's really where it shines. And yeah, it's available on GitHub. If you haven't seen it already, go check it out. And just wanted to give you a very quick overview of like what the code also looks like, not just in terms of the high level concept. Here we have like the very minimal example of how a Qt application might look like. And again, like with CXX, you have a module that actually describes your sort of bridge between C++ and Qt. And there you add this CXXQt bridge macro on top. So anything that starts with a hashtag and these square brackets in Rust is a macro that can generate code for you. And like in this bridge, you can then use all the CXXQt features. Also, because we're a superset of CXX, you can use all the normal CXX features, which in this case, for example, means that you can declare something as coming from C++. For example, in this case, okay, we want to get access to QString, which we've already wrapped for you. So if you include the correct header file, which in this case is CXXQlib qstring.h, so you can't just use QString as you normally would, because we've like added a bunch of methods that we need to wrap it. but it's still relatively easy, right? You just have to remember to write CXXQt in front, and then you can include QString as a type from CXXQt, and that will work then and CXX will check that you're using the right types and everything, and that it's just working out. And the way you then define QObject is actually you just write a struct, which is similar to a C++ class, but you don't have inheritance and everything. But like this, there's not structs and classes in Rust. There's just structs. You just declare one of these structs as you would normally in Rust code, and you just add this QObject macro on top. So similar like to the QObject macro that you have in C++, basically, you just say, okay, I want this to be a QObject. Then it has these fields, and you can just have normal fields that are Rust only, but you can also then have fields that you mark with QProperty. So again, very similar to how you would do it in C++, but just a little shorter, because that will already set up setters, getters, and notifiers for you. You just add QProperty to a field, and as long as that field is sort of CXX compatible, it will work, or should work. And in this case, we just declare that we want to have a number, which in this case is an integer. So i32 is like a 32-bit integer, which is the default in Rust. And we also just want to have a Q in our Q object, so nothing special here really. We then can implement a default implementation, because we kind of need a way to instantiate our struct from C++, and it will always just choose the default. So here you can choose like whatever your Rust struct will look like when you instantiate it from C++, or especially from QML, because QML kind of expects a default constructor. So think of default really as the default constructor for that type. We can add code to our QObject, and you may notice that here it says it's QObject : myObject. That basically says, okay, we don't want to implement this on this myObject struct directly, but we want to implement this on the QObject version of the myObject struct, if that makes sense. Because we really generate these two things out of this QObject that we declare above. And the one is the normal Rust struct, and the other one is that C++ subclass. And so QObject : myObject then refers to that C++ subclass. And that has access to the internal Rust struct, which we can, for example, access in this increment number function, where we say, okay, we want to have a mutable reference to self. Needs to be pinned. That basically says, okay, you can't like mem swap this or something like that. But that's just a normal Rust concept to kind of define objects that are non-movable. Because by default, everything is movable in Rust. So here we're saying, okay, we want this to not be movable so that we don't screw up any pointers that we have in C++. And then we can say, okay, from self, I want to have the number. And then we can just set a new number. These functions we didn't declare anywhere, but because we declared number to be a Q property, it has automatically generated these getters and setters for us. So in this case, number as the getter and set number as the setter. And if we do set number, it will actually automatically also emit a notification signal so that, for example, QML gets the updated state. And the only thing we have to do is declare this as Q invocable. Again, very similar to C++, but also very easy to do. And it will expose this both to C++ and to QML. Then we also have another method that actually doesn't take a mutable self, but it just prints the values we currently have. In this case, we're actually not taking them from the object itself. You can just do that from C++ and just pass in normal things like normal. So in this case, right, this would be your const ref to a QString. Your number you'd pass by value. You could also pass the QString by value if you really wanted to. And if we then look at how the QML code looks like in QML, we can actually just declare, hey, I want to use a myObject. We can assign the number and the string. If I pull this up in Rust again, right, we've just declared this with the names number and string. So in the myObject, we can just go, okay, I want my number to be 1. I want my string to be my string with my number. And you'll notice that here we're actually using a binding to number again. And that actually just works like normal, because number, right, emits the right notification signals, and all of that just works by default. And then we have like two labels for both values. We have two buttons, one that calls the increment number function and the other that just calls that say hi function. And you'll notice that here say hi was declared in Rust with snail case, but we are automatically converting that to camel case so that you really just don't notice any difference from QML, whether it's a Rust-based Q object or not. And in Rust, you also don't notice a difference because a snail case is the default. So we automatically convert it for you. Then we just access the fields as we normally do, right? These are Q properties, so no problem to access those. Once we've registered them for QML, so in our C++ code, we actually just go, okay, I want to include from whatever CXXQ has generated for me, the myObject file. In this case, we always add the CXXQ to be specific that this has been generated by CXXQ and not CXX. Once we've included that file, we just have this myObject class that sort of mirrors the myObject class or struct in Rust. And this is, again, just a normal Q object. You can do anything that you would do with a normal Q object. You could, call new myObject and instantiate it, no problem. That all works. And we can also just register the type for QML like we normally do. And that's exactly what we've done here, which is why we can use it from QML. And if we then run this, in this case, this is a CMake-based build, we can then have this nice QML application that has the number, the string, and again, you'll notice that the binding here has worked. This is the right number for that we want to have in a string. We can increment it, and then it will increment it both in the string and in the number because the binding works. So we can do that. We can call the say hi method, and then we'll have this string that we've defined in Rust, and that's printed via Rust mechanisms. But in the end, it's just all pretty seamless. And that's basically the sort of basics of CXXQt. And if you want to learn more, check out the repository. Or we also have a book online that you can read. And thank you.